today we're going to start on complex numbers. And specifically, that's the number I. I actually equals square root of -1. Okay, so all those negative square roots that we couldn't do anything with before, now we can do something with them. Okay, so the imaginary number is defined as I equals square root of -1. But if you square both sides, you get I squared equals square root of -1 squared. Okay, remember the square and the square root cancels each other out. So you get I squared equals -1. So you know that I equals square root of -1, and I squared is just -1. Okay. Now remember that if you have the nth root of any product, let's say A and B, you can just separate those as long as you're just multiplying. So you have the nth root of A times the nth root of B. Okay. So we're going to use that to convert the next couple of examples. Okay, so what if we write each expression in terms of I? Okay, so let's say for A, we have square root of -9. For B, we have the square root of -7. And for C, let's say we have the negative square root of -18. And let's say for D, we have the square root of -24 over 49. Okay, so for problem A, we have square root of -9. Okay, which is just like saying the square root of -1 times 9. Okay. So remembering this rule up here, we can just separate them. So you have square root of -1 times square root of 9. And again, even though square root of 9 is plus or minus 3, they just kind of pay attention to the positive. So we know that I is equal to, well, square root of 1. -1 is equal to I. And square root of 9 is equal to 3. But you can just write it as 3I. Okay, so same thing with B. If you have square root of -7, you can make that square root of -1 times 7, which is just square root of -1 times square root of 7. square root of 7, you can't simplify it anymore, so that stays the same. Square root of -1 is I. So you get I times square root of 7. Or sometimes they'll write it as square root of 7I. But make sure you put the I on the outside of the square root. But if you did put it in front, it wouldn't be wrong. All right. Any questions so far? All right. So let's say for problem C, we have negative square root of -18. So bring that up a little. Okay. So really this negative is on the outside, so that's just multiplying -1 times whatever answer you get. So that's negative square root of -1 times 18. So if we separate that, it's still negative square root of -1 times square root of 18. And remember that 18, you can make that 9 times 2 because you have a perfect square. So that's negative, so that can become I. So you have negative I square root of 9 times 2. And I'll just continue it on the next one. So you have your negative I. Remember, that's just square root of 9 times square root of 2. Kind of separate that a little. Square root of 9 is 3, so you end up with negative 3I square root of 2. Or you may see negative 3 square root of 2 and the I is on the other side. So wherever you put it, it would still be correct. All right. Any questions on that one? All right. So for D, you have square root of -24/49. Kind of separate that a little bit since we're running out of space. So -24/49. Okay, so just like before, we can just get that -1 times 24/49. So you have square root of -1. And that square root of 24/49 can just be square root of 24 over square root of 49. Okay, that square root of -1, that just becomes I. And square root of 24, remember that's 6 times 4. That's square root of 6 times square root of 4. Yep, should have put it the other way around. Over square root of 49 is just 7. Okay, that square root of 4 is 2. So that becomes 2 square root of 6 over 7, and we'll put the I behind it this time. All right, so any questions on that one? Yes?
Would it be okay to write a 2I root of 6 over 7?
Oh yeah, if you want to put it up top, you could. If you want to put it in front, you could. So any one of those would be okay.
Cool.
So even though it's not a variable, you kind of treat it like one the way you do that one. It moves around just like you would a variable. All right, leave that up for a few more seconds. Okay, so really all that tells us is that in general, for a positive real number. I was about to put rational for some reason. B, square root of negative b equals I square root of b. So you don't always have to factor it out to -1 times this. You can just, when you see that negative, you can just automatically make it I. Oh, straighten that up a little. Okay. The reason b has to be positive, because if you have the negative of a negative number, it's positive anyway, so. Okay. Now the definition of a complex number kind of changes a little bit. So a complex number is any number that can be written in the form a plus bi. Kind of straighten that up a little. Okay, where we know that a and b are real numbers, and we know that I is equal to square root of -1. Okay, so when we do have it in that particular form, for a plus bi, the a, they say that's the real part, and the b is what they call the imaginary part. All right, so let's say, for example, if you see 2 plus 11i. Okay, this is your real part, and this is your imaginary part, where in this case your a is equal to 2, and your b is equal to 11. Okay. Or let's say if you had 6 minus 9i. Okay. This is your real part. This is your imaginary part, where your a is equal to 6 and your b is equal to -9. Okay. So what if you had -1/2? You can actually write that, bless you. You can write that as a complex number. Okay. You can write that as -1/2 plus 0i. Okay. Or in this case, this is your real, and this is your imaginary part, where your a is equal to -1/2, and your b is equal to 0. Or what if we had square root of 3i? can just rewrite it as 0 plus square root of 3i. We know this is our real part. This is our imaginary part, where a is equal to 0 and b is equal to square root of 3. So any real number can also be written as a complex number. Okay. Any questions on that so far? All right. I'll leave that up for a few more seconds. It looks like everyone's done writing. Okay, so what if we wanted to write each number in the form a plus bi? Okay, so let's say for problem A, we want to write 6. Say for problem B, we want to write the square root of negative 64. So for problem C, we want to write negative 2 plus the square root of negative 63. So each one of those, we can write it into a complex form. Okay, so if we start with A, if you have 6, you can just make that 6 plus 0i. Okay, you'd be pretty much done with that one. Okay. Now for B, if you have square root of negative 64, you can just make that I square root of 64. Okay, so we know 64, square root of 64 is just 8, and 8 times 8 is 64. So we can just make that 8i if we wanted to. But remember, you have to write it in that form. So that would be 0 plus 8i. All right, so for C, we have negative 2 plus square root of negative 63. So we can just get that negative 63 and convert that. So we have negative 2 plus I square root of 63. Okay. So now we do have a perfect square in 63 since it's 9 times 7. So we can just make that negative 2 plus I square root of 9 times 7. Or we can make square root of I times square root of 7, since we know we're going to separate it. Okay. Know that square root of 9 is just equal to 3. So we know negative 2 plus this becomes 3i square root of 7. Or 3 square root of 7i. And the only reason most people will put it in front is because if you put it right behind it, it looks like it's under the square root, which would be wrong. So you want to, in most cases, I'd put it in front. It's really easy to type in your answer, and that square root ends up covering that I also. Okay. Any questions on any of those? All right. that up for a few more seconds. Looks like everyone's done writing. So now is going to adding and subtracting. Complex numbers. Okay, so a few steps or guidelines. Okay, so first thing you want to do is make sure that all terms should be in the form A plus BI, or A or BI. So it should be in terms A or BI. So you want it in terms of a real number or an imaginary number. You don't want the square root of a negative number when you're adding. Real or imaginary numbers. Okay. And two, then you're going to add your real numbers together and your imaginary numbers together. Add or subtract. Add and subtract the real parts to real parts. And imaginary parts to imaginary parts. Okay, so it's really just identical to adding and subtracting variables. If you have 3x plus 2x, that's going to equal 5x. If you have 3i plus 2i, it's going to give you 5i. So even though it's not a variable, it still follows the same rules. Kind of like your square roots. Okay, so you want to remember that I is not a variable. But we treat it like when we add and subtract. When we add or subtract. Okay, so let's say, for example, we wanted to add 8 plus 4i plus 12 plus 8i. Okay, so this is all addition, so we can just drop the parentheses. So that's pretty much just 8 plus 4i plus 12 plus 8i. So the same way you would just have 4x plus 8x, you add your real parts and you add your imaginary parts. Okay, so we have 8 plus 12, which is 20, and 4 plus 8 is 12, so 20 plus 12i. Like I say, do it just the same way you would if it was a variable.
So it will be the final answer, or we can take out the common multiple.
Oh, nope, you just leave it like that. Yep. All right. Leave that up for a second. All right. So let's say if we wanted to subtract. Okay, so let's say if you have -6 plus 4i minus 3 plus 2i. Okay, and we just rewrite it. Oops, there we go. Now this one, you can just drop the parentheses there. So you have -6, bless you, plus 4i. This one, just like you would if it was a variable, you just distribute your -1. I mean -3, sorry. Nope, -1 to -3. So you have -3 minus 2i. And just like we did before, we combine our real parts and we combine our imaginary parts. Okay, so you have -6 minus 3 is -9. And 4 minus 2 is 2. So you have plus 2i. All right, so what if we want to add 7 minus square root of -16 plus 9 plus square root of -4. Okay. So before, it was already in real and imaginary form, so we didn't have to do anything. This one, we have to put it into real and imaginary form. Okay, so we know we have 7 minus square root of -16. We can just make that 16i, or I, square root of 16, plus 9 plus square root of -4. We can just make that I, square root of 4. Or if you wanted to just skip that step and just go right to making that 4i, you could have. But this becomes, oh, don't really need the parentheses since we're adding, so we can drop those. You have 7. Square root of 16 is 4, so 7 minus 4i plus 9 plus square root of 4 is 2, so that becomes 2i. Okay, and just like before, we combine our real parts and our imaginary parts. Okay, so 9 and 7 is 16, and -4 plus 2 is -2, so you have -2i. Okay, any questions on that one? All right, leave that up for a few more seconds.